pure resistance and pure inductance. The pure word is very important. It means we are simply considering ideal case, but definitely when we go through further questions, nothing is pure exist in the real world. So definitely for the theory point of view, we can consider the pure inductance or pure resistance. But for the further questions, we have to introduce some new thing that will come later on, no problem. But in the starting point of view, keep in mind we are discussing the starting only with the pure resistance and pure inductance. So suppose if this voltage source, this symbol definitely for the alternating, and here is the resistance, pure resistance and pure inductance. So definitely if current goes through with the help of this voltage source, first of all one resistance is there, that is voltage drop VR, and voltage drop VL is also there. But in this case, if inductance is pure, there is no voltage drop. As much voltage or power it consumes, it will deliver the same later on. But for right now, what we have to understand, what is the role of the inductance. Suppose in resistance, voltage and current will remain in the same phase, not an issue. But whenever it is encountered through any inductance L, so if current is shown through this static factor, you can say, so the voltage is shown 90-degree leading to the current. It means whenever current pass on through any inductance, the voltage will get a phase shift, advanced phase shift of 90-degree. In means the beginning you have to keep in mind that in inductance voltage will lead the current. One basic formula is also there. Maybe you encountered somewhere also CIVIL, civil. What is the matter if you this three combination and this three combination is very important to keep in mind. It means in inductance here V is coming before the I, it means current. It means in the inductive circuit or inductance, voltage leads the current. Voltage is coming before the current, it means it leads the current. And why is the 90-degree phase shift? Because we are assuming in our circuit inductance is pure inductance. So that's why it is having the phase shift, advanced phase shift of 90-degree. If it is not pure, definitely it is not going to be 90-degree. But in our case, we are assuming it is pure inductance. So that's why we are saying it is having a phase advance of 90-degree. It means if any circuit, if resistance and inductance are there, then in due to this inductance part, voltage will lead the current by 90-degree. That is also given by the simple remembering formula, not a formula, symbol a symbolic remember thing, civil, CIVIL. So always remember in inductance, this. And for the capacitance point of view, when we go through later on, in capacitance current leads the voltage, but right now we are discussing with the inductance portion. That's why I simply remind you to keep in mind that in inductance voltage leads the current. So in any AC circuit, first of all, after the circuit diagram, we have to know how to draw their static portion diagram or phase diagram to understand, because alternately V is equals to IR will be applied to all the circuits. But for AC circuits, this formula, Ohm's law, definitely Ohm's law, is basically only applicable for the circuits which is encountered with only resistance portion. But in for alternating current, no such circuit exists. Every even wire also shows the property of capacitance also and inductance also, not even the particular component. Without component also, they shows the property of inductance and conductance. That is also we gone through later on. But right now, keep in mind this formula is only applicable this formula is only applicable if we are only dealing with the resistance. But whenever we have to discuss with the inductance and conductance, capacitance also, then we have to discuss some more thing. And what is the portion? The first thing. Suppose this is the voltage in resistance as per this diagram. We discuss this is the voltage. So this is the voltage factor for the resistance. We are taking the same phase. Suppose this is the xy plane, x axis, y axis. So when we have to take some reference. So the reference point of view is always taken to the parallel or to the similar to the x axis. So this is the phasor diagram for the voltage through resistance. As I already discussed with you in the inductance, voltage leads the current by 90 degrees. So how we have to show this in the phasor diagram? This is the voltage through inductance. This is the 90-degree phase shift in respect of the voltage in resistance. So whenever we have to, this is the resistance portion, this is the inductance portion, but overall both are connected in the series circuit. So we have to find out some resultant portion. So what will be the resultant portion in the factor point of view, in the vector theory? There are two vectors. This is VR and VL. If we have to find the resultant, what we have to do, from the tail of the first vector, we have to connect head of the last vector. That will be the resultant. This is the resultant portion always. One angle is there between